Hello, this is zebracode.io, and we are on lesson 6, and we're looking at branching and if statements, and this is the demo. Let's go ahead and open a command prompt, and that's a desktop application. We're going to be doing our demo in the Windows environment here, and we can also type in idle, IDLE, and that's also a Windows application if you can't find it, so just filter it on the appropriate Windows applications. Now, once we start, we can create a new file, and we're going to create a new file, and we will be typing in the basic test application that we did before. Now, what you want to do is set up two environments. You have your command prompt here, and then you have this idle window, that our text editor that we've just created, and we're going to be flipping back and forth between our command prompt to execute the code, and we can type our code here and save it using idle. So we're going to write a quick program. test is assign the value of input into a test score, and then we're going to take that test score and convert it to a float, because anything used from the input command is a string. So now that we have a value, a new test variable that we can work with in numerical terms, and we can say if test is equivalent, double equal sign here, is equivalent to 100, then we're going to print perfect score. Now, the next thing we want to do is do a few else ifs, and again, we can have many else ifs, or you can have zero, so it's purely optional, but we're going to have else if test is greater than 90.0, then we're going to print that the student got an A. So this makes sense, and we've seen this before. Now, if you go to the if statement and it's not a perfect score, then it goes to the next else if, and then if that's not continues, then it continues down. So in this case, if the test is greater than 80, we're going to print B. And else, this is else, you can only have one else, or you can have zero elses. But in this case, else is if nothing else is true above it. We've gone through the if, the else if, and the else if. In this case, we're going to print study more. So let's save this. We're going to save this in our homework folder under lesson 6, and I'm going to call it demo.py. Remember to call it, don't forget the extension, the .py file, and we can save it. And so this file is located there, and in order to run it, we go to our command line, and then we need to now navigate to this file, and we can cd into documents, it's plural, and then cd into homework, that's change directory into lesson 6, and I can do a dir here, and I can see all my files that I have here, and one of them is demo, as we can see. So I can use CLS. CLS is a command in the Windows environment. It's slightly different. I think it's clear in the Linux environment. But anyway, we can now type python demo.py, and we can start entering our score. So I'm going to enter a score of 100, and it says perfect score. Now I'm going to enter a score of 95. I get an A. I can enter a score of 83, and I get a B. So it's doing everything that I expected. However, let's look at this code a little bit closer now. We're making some assumptions about the score. So what happens if I try something a little bit not expected? And remember, I'm going to, let's say, a score of 105. And if I have 105, I get an A, not a perfect score. So if you look at our logic here, remember, if statement, if test is equivalent to 100, it's going to print perfect score. But if it's something different, if it's 105, for example, it falls to the next one, and we get the else if test is greater than 90. So those are things to be aware of, and those are the nuances of if else and if else statements. So get plenty of practice of that. Make sure the logic is doing exactly what you want. There's a lot of ways to simplify or to correct that type of error. We can make sure all the scores are maximum of 100, for example. So let's look at another example. One idea when we're doing iteration, I know we're doing branching, but in iteration, you could do something over and over again, and each guess, it gets a little bit better. So here's a problem in which we're going to calculate the square root, and the next guess, we have this formula. It's based on mathematics of the Newton method, but either way, let's just take it for granted. We know that with our next guess, it's going to be a little bit better if we apply this formula. So we have a problem. It's going to be, we're going to try to find the square root of 25 and our first guess, and it could be anything, but our guess is going to be 2, and our margin of error is going to be 0.001. And the idea that as we get closer and closer, we get a better estimate, then we're going to fall out. So let's explain. I'm going to go line by line and understand that main idea is what we want to do is get each guess to get better, and finally we're going to get so good that we're going to drop out of the loop. So while true, so this true statement is always going to be entered. We're always going to enter this while loop, because while true, and then true, it's always true. So the only way we're going to get out of that is a break. So the first thing we're going to do is print our guess. That's the guess that we started it. And then the first time it's going to be 2. And then we use our formula. The next guess, this is going to be a little bit better each time. The next guess is going to equal, this is the formula that we learned. It's going to be in parentheses, g plus x divided by g, and the whole expression in parentheses divided by 2. So I'm going to create a new variable called change, CNG, or CHG, and that's going to be assigned the value of guess minus the next guess, or guess minus the little bit better guess. So the idea is that each time the guess gets a little bit better, at a certain point, it's going to get so good that I'm going to drop out of the loop. And so that's why I'm using CHG to represent the change. Now, if change is less than 0, then I want to make it I want to multiply it by -1 to make it positive, because when I'm comparing it, I'm always going to be comparing positive numbers. So if change is less than 0, then I'm going to say change is assigned the value of change times -1. So that's going to make it back to positive 0. And now I can use another statement, if change is less than the margin of error. So each time I go through here, if that change just changed so little, that's going to be less than my margin of error. This is the only time I'm going to exit the loop by using a break statement. So with iteration and branching, we can really build some powerful programs. Now, the last thing I must do is I must take the current value of a guess and assign it the next value of guess, because as I go through this loop again, each time it's going to get a little bit better, because at the end, I must make the current guess value equal to the next guess. So this is iteration, going something over and over again, and I have my branching statements here, which is going to help me break out of the loop, or break out of the iteration. So let's go ahead and run this. So I've called this square root. So let's go Python square root.py, and let's run this program, and I get an error, and it says G is not defined. So of course, G, if you look in here, that's just a shorthand. It really should be guess. So I'm going to correct my error. We're going to get lots of errors when we code, and we should be comfortable with getting those error messages and correcting them as we see. So let's clear this, and let's run this again, Python square root. And here we go. Each guess, we can see we have 2 and then 7.25. Each time it's getting a little bit closer, then it gets 5, and then we finally say the square root of 25 is 5. So this went through 1, 2, 3, 4, 5 times. We went 5 times. Each time it got a little bit better. We started with 2. We got closer and closer to 5. Let's increase the margin of error to make it even smaller. So I've added a bunch of zeros to make the margin of error even smaller. And let's run it again. And now we see that it took 6 times to go through, because each time it's getting a little bit closer, but the margin of error got smaller. So it took an extra iteration. So this is a very quick way to find square root using an iteration method, and it's not unlike how our calculators and how computers solve problems, because they can't instantly find the square root. They have to go through an algorithm such as this to find it. This is zebracode.io. We're on lesson 6 and learning about branching. We started by looking at a classic branching problem that deals with test scores, and then we looked at what you can solve by combining both iteration and branching together, some very complex algorithms.